Okay, so in this video, we are going to graph tangent and cotangent functions. And this video primarily is for those who were absent on the Friday that we went over this lesson. A lot of you stayed home for safety measures. Okay, so again, how do I graph a tangent function? Well, the way you graph a tangent function is to write the reciprocal, actually it's called the quotient identity. And the quotient identity for tangent x, right, is basically sine x over cosine x. Okay, so if you look at it right now, right, I actually have a function in the denominator. I can't just randomly plug in points to graph this. What I'm going to have to do is to recognize that way back in chapter 6, whenever I have something in the denominator, right, in the context of graphs, it's going to create vertical asymptotes. So if I set my denominator equal to 0, I'm going to find the x values for which this function is not defined. Okay, so let's start by finding the VAs by setting cosine of x is equal to 0. And now you just kind of have to know your unit circle, right? For which x value, for which angle is the x value 0 on the unit circle? And the x value 0 clearly over here, right? 0, 1. The x value is also 0 over here, right? 0, -1. And the angle for that x value is pi over 2. The angle for this x value, for which is 0, is 3 pi over 2. Okay, so you could write x is equal to pi over 2. X is equal to 3 pi over 2. Okay, so these are the first two vertical asymptotes, but let's say I want all the vertical asymptotes, right? Notice it's going to repeat every pi radian. So if I go look at my unit circle, right, the distance from here to here is a full pi. The distance from here to here is a full pi. Distance from here to here is a full pi, right? It's just going to keep going around the circle. And so these VAs are just going to keep repeating itself, right? So the next VA, right, I would just take 3 pi over 2 and add pi. You can also see this by calculating the distance from here to here. Okay, so let me just quickly show you the work. The distance between pi over 2 to 3 pi over 2, if you don't believe me, is 3 pi over 2 minus pi over 2, which is just 2 pi over 2, which is just pi. And this happens to also be the period. It's also the distance between the VAs. This is called the period and the distance between VAs. And so on a quiz or test, if I say, hey, find all the vertical asymptotes of this function, you would take this first VA right here and you would say all the VAs are x is equal to pi over 2 plus whatever your period is. In this case, the distance between here and here is a full pi plus pi n, and n is an integer. Okay, so that means you can also go backwards, right? N could be 0, it could be -1, it could be -2, -3, or it could be +1, +2, +3. And this will give you all the VAs, right? Because if you look at the circle, right, the distance from here to here is pi, distance from here to here is pi. It's just going to keep repeating itself. Or you could just do right minus left. That will give you the period, which is also the distance between these two VAs. All right, well, if this is the vertical asymptote, right, you could already state the domain of this function by saying all x cannot equal pi over 2 plus pi n, right? That will give you the domain of this function because remember in your graphs, right, your graph can never ever cross a vertical asymptote because that's implying that you can divide by 0. And you know, of course, that's not true, right? Being a good math student, you know you can never, ever divide by 0. All right, so I only have some VAs right now. And let's graph two periods of this. So we have pi over 2 and 3 pi over 2. I'm going to put it somewhere over here. X is equal to pi over 2. And x is equal to 3 pi over 2. Okay, so if we go back here to our vertical asymptotes, right? If n is equal to 1, right, you would have 2 pi over 2 plus pi over 2, you have 3 pi over 2, right? This is the first the second vertical asymptote, right? Well, let's say n is equal to -1. Pi over 2 plus negative pi will give you negative pi over 2. So I can have a negative, I can have another VA right here. X is equal to negative pi over 2. Okay, so these are, I would say, the first three VAs I have. And the way you write your VAs, of course, is you start with the first least positive one and then plus the period times n. Had you written negative pi over 2 plus pi n, that's not wrong. But it's the first least positive one. In this case, is x is equal to pi over 2, okay? All right, so again, hopefully you can see how I got negative pi over 2. I just plugged in n is equal to -1 over here, going backwards. All right, now, how do we actually graph this? Well, from here, I'm going to actually just plug in some points, okay? So I want to plug in some smart points in my function, f of x is equal to tangent x, which is equal to sine x over cosine x. And what are some smart points that I can plug in? Well, some smart points that I can plug in based on my knowledge of the unit circle is if I plug in pi over 4, right? Well, the sine of pi over 4 is root 2 over 2. The cosine of pi over 4 is also root 2 over 2, right? Well, root 2 over 2 divided by root 2 over 2, that's a nice number. That's just 1. Another nice number I can plug in, right, is negative pi over 4. And likewise, if you plug in the sine of negative pi over 4, right, the sine of negative pi over 4 is negative root 2 over 2, right, because you're in quadrant 4. The cosine of negative pi over 4, if you think about it, is positive root 2 over 2. So negative root 2 over 2 divided by positive root 2 over 2 is -1. Okay, so in case you didn't realize that, right, this is negative pi over 4. The x value is the x value is positive root 2 over 2. The y value is negative root 2 over 2. Okay, so tangent, right, the ratio of y is to x is -1. Okay, so now I'm going to go back to my graph over here. This is pi over 4, right? This is negative pi over 4. This is 0. And if you plug in, or sorry, if you write your axes right here, this is +1, this is -1. And there's one last value we can plug in, right? It's an easy value that we can plug in. We can plug in 0, okay? So the sine of 0, right, when the angle is 0 radians, the sine of 0 is 0, the cosine of 0 is 1, 0 over 1 is 0, and so we actually have an x-intercept right here. Okay, so at pi over 4, we have +1. At negative pi over 4, we have -1. And your graph kind of looks like your cubic function. It just looks like this. And that's pretty much it. This graph, which repeats itself, is periodic, right, is going to look identical for over here. Okay, so for this portion of the graph, it's going to look like this as well. And another thing to consider, right, is the x-intercepts, right? The x-intercept right here, I started at 0, and the distance from here to here will give you the next x-intercept, right? Well, just like I mentioned that the distance between vertical asymptotes is essentially your period, right? The distance from here to here, 1 period, right? This minus this is just pi. Well, the distance from here to here is also going to be pi. So for my x-intercepts, I could say all x is equal to 0. The distance from here to here is pi, so plus pi n. Again, where did you get this number right here? That's just the period. Where did you get this number? I plugged it in. But actually, as you graph these, you can just say, hey, the x-intercept is really just the midpoint between these two vertical asymptotes. In other words, if you want to calculate the midpoint, you could do pi over 2 plus negative pi over 2, divide by 2. That will give you this point right here. How did you get pi over here? You could do 3 pi over 2 plus pi over 2. Right? It's the midpoint. I'll even show you the work. 3 pi over 2 plus pi over 2, right? And then divide by 2. Okay? So over here, you're going to get 4 pi over 2, which is 2 pi. times 1/2, which will give you pi. So just a quick recap, right? The distance between the vertical asymptotes is always going to be the period. The distance between the x-intercepts is always going to be the period, right? The period is just pi. And once you have the shape of one section of the graph, right, it's going to look exactly the same for the next set of vertical asymptotes. Okay, so let me finish this problem, right? We have the vertical asymptotes, we have the domain, we have the x-intercepts. There is no amplitude, okay, so that one you don't have to worry about. The range is pretty much going to be minus infinity to infinity, right? The y value is going to go on forever. And that's your tangent function. Okay, so let's move on to cotangent function. The cotangent function is found or graphed the exact same way as I graphed the tangent function, except you know the reciprocal identity for your cotangent function, right? Instead of sine over cosine, is cosine over sine. Okay, so the way I calculate the vertical asymptotes is identical to what I did over here, right? I set the denominator equal to 0. And then now I have to solve using my unit circle. Okay, so where is the y value, right? Remember, sine is the y value in the unit circle. So if you forgot, you can just sketch it out, right? The y value is 0 here at, over here, 1 comma 0. And negative 1 comma 0, right? The radians for which the y value is 0 is 0 radians and pi radians. Okay, so these are going to be your first two VAs. I'm going to say x is equal to 0 or x is equal to pi. Okay, so hopefully you guys can still remember your unit circle, right? This means the sine of 0 is 0, right? The sine of this angle, which refers to the y value 0. The sine of pi, right? The y value is also 0 over here. Okay, so, right, just like the previous problem, right? The distance between here to here is a full pi radians. And the distance between from here to here is a full pi radians, right? So actually I can find all the VAs by saying all x is equal to 0 plus the distance from here to here is pi plus pi n. Or you can simplify and just say all x is equal to pi n. Okay, so on this previous problem right here, right, where I wrote 0 plus pi n, you could just write all x is equal to pi n for the x-intercepts. Okay, so you can just add 0 plus pi n, which is just pi n. Okay, so we got the VAs. Our first two VAs are 0 and pi. And while you have the vertical asymptotes, why don't you state the domain while you're at it? You could say all x cannot equal pi n, right, where n is an integer. And based on your knowledge, right, of the previous problem, right, you can actually calculate the x-intercepts by finding the midpoint of these two VAs, right? The midpoint of these two VAs is found by saying 0 plus pi, right, and divide by 2. And so your first xint, right, is pi over 2. And the period, which we calculated, right, the distance between the two VAs is just pi. You can say all x is equal to pi over 2 plus pi n. Okay, we'll see that. We'll verify that on the graph a little bit later on. Okay, so let's graph it. Okay, so my first two VAs are 0 and pi. And, okay, so from here, what do I do, right? I also know I have an x-intercept at pi over 2. But let's plug in some points just to verify that, okay? So likewise, I'm going to write f of x is equal to cotangent of x, which is equal to cosine of x over sine x. Okay, so I want to plug in some smart points over here as well. What's a smart point for me to plug in? I don't want to plug in 0 or pi, right? Those are the values that are going to make my denominator 0. I want to plug in, pi over 2. Let's plug in pi over 2. Right? If I plug in pi over 2, cosine of pi over 2, we said was 0. The sine of pi over 2, right, is just 1. 0 over 1 is just 0. So we do have an x-intercept at pi over 2, right? We can verify that. And notice we could also plug in the midpoint between the x-intercept and the vertical asymptote, right? The midpoint between these two values, let's calculate midpoint. Pi plus pi over 2, right, divided by 2. Well, what is that? That's 3 pi over 2 times 1/2, which is 3 pi over 4, okay? So this point right here is 3 pi over 4. This is the midpoint between the x-intercept and the VA. So if I plug in 3 pi over 4, well, the cosine of 3 pi over 4, well, if you think about it, right, I'm in quadrant number 2. That's positive root 2 over 2. The sine of 3 pi over 4, the cosine of 3 pi over 4 is negative root 2 over 2 because I'm in quadrant 2, right? The x value is negative. The sine of 3 pi over 4 is positive root 2 over 2 since I'm in quadrant 2. So negative root 2 over 2 divided by positive root 2 over 2 is negative 1. And let's plug in another smart point. That smart point would be the midpoint between the x-intercept and here, right? So 0 plus pi over 2 divided by 2 is pi over 4. That's just the midpoint between those two values. I did that in my head this time. And if I plug in pi over 4, right, the cotan pi over 4, which is the cosine of pi over 4, root 2 over 2, divided by the sine of pi over 4, root 2 over 2, which is just positive 1. Okay, so these are the three values that I'm going to plug in. And it looks like my y is going to go from negative 1 to 1. So I'm going to write that in. And so at pi over 2, it's 0. At pi over 4, it's at positive 1. At 3 pi over 4, it's at negative 1. And now you have a shape of the graph. It's going to look something like this. Basically the opposite of your, tangent function, right? It kind of gets flipped across the y-axis, if you will, and phase shift as well. Okay, so if I say, hey, give me 2 periods of this function, right? Of course, you can go this way right here and say, hey, the distance from here to here is a full pi. You can say x is equal to negative pi, and you can graph another portion of the graph. This would be a full 2 periods. So let's verify. Let's see if what we wrote over here is correct, right? We said that our x-intercept is basically pi over 2, which is this value right here, right? Plus pi n. This pi right here, how'd you get that? That's the period. The distance from here to here is a full pi, right? So if I ask you, hey, what is this x-intercept? Well, you can calculate it by saying, hey, that's just the midpoint between these 2 points. Or you can plug in n is equal to negative 1, and you get negative pi over 2. Okay, so this will be full, 2 full periods. And just to finish up the problem, right, the domain is this, the range, not too difficult, minus infinity to infinity. And one thing I want to mention before I conclude this video on the parent functions of tan and cotan is that the period, okay, the period is no longer 2 pi over b, okay? The period for these functions are just going to be pi over b. Again, b is your horizontal shrink or stretch factor. This is for cotan and tan, okay? The reason why I want to mention this is because, for your sine, cosine, secant, cosecant, the period is always 2 pi over b, right? Well, now the period is pi over b. And, if you go back and just look at the equation, right? If I ask you, hey, what is the b value? The b value you would say is 1. And then say, hey, what's the period? You would say, the period of tangent is pi over 1, which is just pi, okay? So likewise, for this equation right here, if I say, hey, calculate the period, well, the period is given by the equation, pi over b. The b is 1, and so the cotan period is pi over 1, which is just pi. And you can see that from the graph, right? The distance from here to here is pi, the distance from here to here is pi, distance between the vertical asymptote, the x-intercepts is also pi, and that's how you calculate the period for tan and cotan, okay? So the only tricky part for you guys, I think, is finding the VAs. That stuff, it requires you to know the unit circle. Looks like there's a lot of material over here. And again, you guys are always welcome to replay the videos, post comments or questions on anything that I post here.